Hello, everybody. Welcome back to part two of Financial Applications, Lesson 3. Today, we're going to continue where we left off from last day, calculating the number of payments from our compound interest equation. Okay, so if you haven't watched the part one, please make sure you watch part one. In part one, we review how to do logarithms, which are necessary for solving for our exponents if we're not going to be using trial and error, and it's much easier once we've gotten used to it to not use trial and error but to use the logarithms. Okay, so that's very important. Next, we're going to go over example 3 and 4 today, and I'm also going to be taking up the compound interest, finding the interest rate homework. There's 3 questions to it, and I know that I did give the answers at the bottom of the page. These are given to us here in the questions. However, there's not really like a full explanation, so I'm going to also give a full explanation for how we get there too. Okay, so let's start with example 3 and 4, and then we'll move on to taking up the homework. Okay, so the first example says, example 3, if you borrow $100 off a friend who charges 13% compounded monthly, how long will it take in years before you owe them $1 million? So just a reminder, the equation we're going to be using for compound interest is A so that's the total amount accumulated that we're owing our friend, is equal to P, so the original principal borrowed, times 1 plus the interest rate to the power of the number of compounding periods. Now, the thing is, the number of compounding periods is actually not the same in this case as the number of years it will take because it's compounded monthly. However, if we know how many times that the interest was compounded, right, we know how many months we borrowed it for, then we can figure out how many years just by taking the number of months and dividing by 12 to find years. Okay, so once we find n, that's not actually the end game. We also then have to convert that to years because the number of compounding periods is the same as the number of months, but not the number of years. If it said compounded annually, then the number of compounding periods and the numbers of years would be the same thing, but that's something I just want to watch for. Okay, so let's write down what's given. So A is given. It says that we want to know how long it will take for us to reach $1 million owing to our friend. Then we have P, the principal, which is only $100. So that's the other thing I wanted to mention here is that it's going to take a very, very long time. I'm expecting this to be a lot of years, even though 13% compounded monthly is a very high rate. It's going to take us a very, very long time before owing them $1 million. So the interest rate here is going to be 0.13 divided by 12. The reason I'm dividing by 12 is because it's this yearly interest rate, but this interest rate is compounded monthly, right? Much like a credit card, they say 20% or 22% or whatever it is, compounded monthly, but that doesn't mean that you're owing 22% at each month. No, it means that that's the annual rate, but it's compounded monthly. So it would be 22% divided by 12 in that case to get how much we're going to be multiplying by each month. So let's type that in. 0.13 divided by 12 is 0.0108333, which I'm going to leave off the 333s at the end and just stop it there. And then we also have n, which is the number of compounding periods, and that's what we're trying to figure out. Because if we know the number of compounding periods, we know the number of months that we borrowed this money for. And if we know the number of months, we can very easily figure out the number of years that many months is equal to. So let's plug this in and figure it out. So 1 million equals 100 times 1.0108 to the power of n. That means that 10,000 is equal to 1.0108 to the power of n. And that means that if we change this to logarithm form, again, if you're not familiar with logarithm form, make sure you go watch the last video or also videos on logarithm form specifically if this part is confusing to you. But if we change this to logarithm form, this is going to become n is equal to log 10,000 over log 1.0108. Now log 10,000 is just 4, right? Because remember 10 to the power of what equals 10,000? Well, 10 to the power of 4 equals 10,000. So that part's easy. It's just 4. The part on the bottom, we need to grab a calculator and actually punch the numbers in. So that's what I'm doing here. Log 1.0108. Okay, so n is equal to 857.4. So that means 857.4 months. So therefore, if that's the number of months, how many years? Well, we're going to divide that by 12. And that's going to be 71.45 years. And I'll make this clear. This is months. We're dividing the number of months by 12 to get the number of years. So therefore, it will take 71.45 years, which makes sense, right? $100, I mean, okay, maybe to some of you, $100 is a lot of money as a teenager. However, $100 in the grand scheme of things is not a lot of money. I bet your parents' utility bills, cost more than that every single month, and your grocery bill and everything like that. $1 million, on the other hand, that is a lot of money, right? Most people don't just have that lying around. So it's a very, very drastically different amounts. And so it makes sense that even with this really high interest rate and being compounded monthly, it's going to take a very, 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 very long time of not making any payments in order to get to this point where we're going from owing $100 to owing $1 million. That's for sure. Okay. Let's move on to example 4. How long will it take in years for $500 to amount to $7,500 at a rate of 7.5% compounded semi-annually? Okay, so first things first, I'm going to rewrite my equation that it's A is equal to P 1 plus R to the power of N. Now, A is the total amount accumulated, so we want to know how long it will take to get to $7,500. Our original principal that we put into the account is $500. The rate is 7.5%, which is 0.075, and it's compounded semi-annually. That means 2 times a year, right? So before it was compounded monthly, and months occur 12 times in the year. Semi-annually means 2 times a year, so every 6 months. So that means we just divide by 2 instead of 12, because semi-annually only happens twice in a year. Months happen 12 times in a year, and if they said it was compounded weekly, then we would be dividing by 52 because there's 52 weeks in a year. Okay, so that means the rate is 0.0375 in terms of our semi-annual rate that we're going to be using. And then n is equal to question mark. And just like with the last one, n is just the number of compounding periods. So what we're going to have to do is we're going to have to, earlier we divided by 12 to get the number of years. This time we'll have to divide by 2 to get the number of years because there's 2 semi-annual compounding periods per year. So if there's 10 compounding periods, for example, and the compounding periods happen twice a year, then that means that there are 5 years that this is taking, right? And so they want to know the number of years. So that's just a quick thing I wanted to mention too, is to make sure that our answer is lining up with the question asked. So let's do this one. A is 7,500 equals 500. 1.0375 to the power of n. So 7,500 divided by 500 is 15. So that means 1.0375 to the power of n is equal to 15. And that means that n is equal to the logarithm 15 over log 1.0375. And then we can just type both of these in the calculator because it's not obvious what log 15 is, nor is it obvious what log 1.0375 is. There's only a few logarithms, like when it's a power of 10, where it would be obvious without using a calculator. Let's see, log 1.0375 Okay, so the answer I got was 73.56. Okay, so that's how many compounding periods. So how many years does that take? Well, let's see. 73.56 over 2 is equal to 36.78 years. So therefore, it will take 36.78 years to accumulate $7,500. And this is very much what we were expecting as well. First of all, the interest rate is, this is a pretty standard interest rate for a lot of investments. And to get from $500 to $7,500, right, we're increasing it by 15 times, right? We're not just doubling or tripling our money, we're multiplying our money by 15 times. So we can pretty much bet that it's going to take a very long time for us to get to that place. Even though this one isn't nearly as extreme as the last one, going from $100 to $1,000,000, this is still a 15x increase, which is a very large increase as well. All right, let's move on to the interest rate homework. There's 3 questions here, and these are the answers we're expecting to receive. Let's start with number 1. Number 1 says, at what interest rate compound annually will $350 accumulate to $637.15 in 6 years, and $3,500 accumulate to $6,195.50 in 7 years. So in this case, we are finding the interest rate. So let's try it. Let's try A first. Well, what do we know? We know that the principal is equal to 350. We know that the amount accumulated is 637.15, and we know that n is the number of compounding periods. In this case, it's compounding annually, which is once per year. So in this specific case, the number of years and the number of compounding periods are the same thing, so we can write 6 here. Now remember, if that's not always the case, it depends, but whenever it says the interest rate is compounded annually, then it is the case. There's no need for a conversion. And we would like to know, what is R? What is our interest rate? So let's plug those numbers in. 637.15 is equal to 350. 1 plus our rate to the power of 6. Okay, so then we're going to 637.15 divided by 350 is going to give us 1.82 approximately is equal to 1 plus r to the power of 6. So now we're going to take the 6th root of 1.82, and we're certainly going to need a calculator to do that. So let's grab our calculator and do that. So the 6th root of 1.82. Okay, so I got 1.10495, so I guess that would round actually to 5, like that, equals to 1 plus r. Now, if we take this to the power of 6, we should get 1.82 back. If we get an answer and we don't get the same thing back when we take it to that power, then we typed something into the calculator wrong. So if you're unfamiliar with how to use the calculator to do this, just make sure that you try that you check it just to be sure. Okay, and then we'll subtract 1 from both sides, and we'll get that the rate is equal to 0.105, which in percentages, the rate would be 10.5%. And the answer is indeed 10.5%, so that's good. We did it. Let's do part B down here, part B, like that. This one's asking about how long will it take, what's the interest rate if $3,500 accumulates to $6,195.50 in 7 years. So right away, we're expecting this interest rate must be less than the first one. If we get something more than the first one, we probably have done something wrong. Now, how do we know this? Because proportionally, it's less money that we're accumulating, right? If this was proportional, it would be 6,3 715 like that, but it's a bit less, and also it's taking more years to accumulate to even this amount that is lesser proportionally. So therefore we're expecting a lower rate. So if we get a higher rate, then that is a problem for us. So let's do it. So again, let's right quickly jot down the important relevant information here, which is that A is equal to 3,500. Or sorry, my apologies. A is equal to $6,195.50 because A is the amount accumulated, not the principal. P is the principal, so that's what's $3,500, and N is 7, right? Because again, it is accumulated annually in this case, and so N, the number of compounding periods, is the same as the number of years, which is good. Makes it nice and simple for us. And then R is what we are trying to figure out. So let's try that. A 619550 equals to 3,500 to the 1 plus R to the power of 7. So let's put that in our calculator. 95.5 1.77 is equal to 1 plus r to the power of 7. So now we're going to take this to the seventh root. So the seventh root of 1.77 must be 1 plus r. So let's see. What's that equal to? Again, we got to use our calculator. We're not going to know that. 7 second function power of 1.77, and that is going to be 1.085. So that means that the rate is 0.085 or 8.5%, and that is what the answer tells us it should be. All right, well, that's it for question 1A and B. Let's do question 2 and 3 next, and then we'll be done for the day. All right, so let's erase this. Okay. Number 2 says, at what interest rate compounded annually would a sum of $350 double in 7 years? So let's answer that question. So what's the interest rate? So that's what we'd like to know. We know that the principal is $350 and that the accumulated amount is $700, right? They're asking how long would it, or not how long, they're asking what's the interest rate if we're waiting for it to double. And double $350 is $700. And then N is equal to 7 because again it says compounded annually. So we can assume that N is equal to 7 also. So that's good. All right, so now let's plug those numbers in and let's figure it out. So 700 is equal to 350. 1 plus r to the power of 7. So that means 1 plus r to the power of 7 is equal to 2, since 700 divided by 350 is 2. So we need to find the seventh root of 2. So let's do that. We're going to need our calculator to find the seventh root of 2, which is 1.1, it turns out, approximately. Or I guess 1.104 if we want to get some more decimals in there. And so that means that r is equal to 0.104, or in percentage terms, 10.4% is our rate. And yep, that is exactly what the answer says, that the rate would be 10.4% if we were to double that money in 7 years, compounded annually. All right, let's do number 3. If a $196.61 credit card debt amounts to $500 in 8 years at an interest rate compounded annually, what is the interest rate that the credit card company is charging? Now, this is a bit odd. Generally, credit card companies compound monthly instead of annually, but this one apparently does compound annually. So we'll see. We'll see what it does. So our credit card balance today is $196.61. And we would like to know when we want the accumulated amount to be $500 and also the number of compounding periods to be 8 since it's compounded annually for 8 years. And we would like to know what is the rate the credit card company is charging us. Typically, credit card companies charge about 20 to 22%, so I'd expect around there. However, it's odd that this credit card company only compounds annually, so who knows? Maybe it's not really a realistic rate for a credit card company to charge, but we'll see. So let's plug those numbers in. So our 500 is equal to $196.61. 1 plus the interest rate to the power of n, which is 8. So let's do it. 500 divided by 196.61 is about 2.5. So 1 plus r to the power of 8 is equal to 2.543, like that. And then we're going to take the 8th root of both sides and punch the right side into the calculator. So we would like the 8th root, the 8th root of 2.543, and that's going to be 1.12375. So that means that r is equal to 0.12375, which is equal to 12.375%, which actually is a very low interest rate for a credit card, and they're pretty generous that they're only charging you annually too, for the interest. But that is indeed the answer for this question, and also the answer that they gave, in the answer section too. All right, well, that is everything for this session today. Next time, we will talk about investing and annuities and the time after annuities when it comes to borrowing, and then we'll be done. So you guys are already pretty much done this unit. We just have a couple more topics to go over before the test. So good work, everyone, and we'll see you in the next video.